Okay, welcome everyone. My apologies for being so late. Excited to finally be here at Viva for live from the studio of Swiss as the topic and health and to discuss this, I have the privilege of experts in the matter, starting with Christophe Berger, who's a digital health business developer at CM, the forefront in industry and research. Then also Lucie Campagne, the project manager for the CNES and the MEDES, Institute for Space Medicine and Physiology. Also Martin AAB, also live from VivaTech, space farmer who enables the pathways to such as that from the European Space Agency as downstream gateway business analyst, working on the commercialization of space.
Thank you, Chloe.
Thank you, Lucy. So we will now start. As mentioned, so the topic is how space can benefit our lives on Earth, and especially in yeah. And so my first question for all of our speakers would be, do you have examples in mind already of things that were developed for space and now that we use? Maybe Sasha, if you would like to start.
1 second. Yes, sure. I think there are quite some spin-ins and spin-offs that had been developed. So if you think about the early days of human spaceflight, little was known about the effects on the human body. So space medicine was doing a tremendous research with regard to this, and a lot of applications, especially in the field of connectivity, had been used also on Earth. I think the highest added value, or more traditional, if you have in disaster risk management, a lot of applications had been developed in this area from the connectivity side as well as Earth observation. But then it's also very much about telehealth. I think it's a field that comes to mind very quickly. And actually, our colleagues have developed a device that's called Tempus Pro. So it was originally used by doctors at the European Astronaut Center to assess and communicate the conditions of astronauts when they're actually returning back to Earth. It's a device that obtains vital signs from blood oxygen, blood pressure, heart activity, but you can also do ultrasound images and communicate via video. So this device was inspired and later also for ambulances or for intensive care units. I think it's a pretty good examples, but I'm sure my fellow speakers have also very great ideas on their mind.
Maybe I can jump on what you just said, Sasha. So I fully agree with your example, and I think that the inspiration of space for Earth and terrestrial application, it's not only like technical use of the same hardware, but sometimes we do have also a little bit of other activities that are more around the knowledge gathering and how to apply what have been discovered in R&D in space, for example, on Earth. But for example, I'm talking about the field of food safety. In the past, so there have been different guidelines to assess that food is safe to eat, for example. And for space applications, they had to be much more stringent and to have like lab procedure in order to guarantee the safety of the food. And this has been a huge inspiration to develop also the standard for terrestrial application. So it's a little bit less technical, but this kind of application, it's also it comes also from the inspiration and the cross-fertilization between the two fields of research. And then talking back about ultrasound, I know the Tempus project, it's a great project. What we have done, for example, on the French Space Agency side, it's to have a robotic ultrasound where you have your medical doctor that is at a certain place, for example, in a hospital, and your patient that is in a remote area, whether it's the International Space Station, but also on an island, for example. And you just have, the patient just have to position the probe of the ultrasound at a certain place, guided by voice and video. from the physician, and the physician can then just manipulate the ultrasound, take the right image, do what he has to do, but remotely, and then perform a diagnostic. And this is quite important because we are lacking of a specialist in terms of ultrasound. So it will allow some people that are not direct access to like large hospital to get a good screening in terms of diagnostic or prevention or disease prevention. So this is the kind of examples that come to our mind.
I have also an example which is actually developed for space, but never been in space yet. So we've been asked already more than 10 years ago to develop system in the view of people going to Mars. And in that case, compared to what Lucy explained, you can't have a direct interaction because communication time is like 15 minutes one way. So if you want to ask a question to your doctors, you get the answer after 30 minutes. So in that sense, we developed hardware garments with monitoring solution, not with all the possibilities that Sasha explained, but already a lot of them, and also a decision support system that was kind of artificial intelligence, but yeah, at that time it was not already the name of it, and to make already like a pre-screening and kind of be the doctor during the 30 minutes where you don't have communication. So to already give to the doctor back on Earth a lot of information so that they can process and that the system is able to do something. And of course, we imagine you don't have any use for that because on Earth you always have a doctor near you, or you can connect to him somehow, or a hospital or whatever. But actually, this kind of system were now tested last year because during the COVID period they were just completely overwhelmed. They had no time, and the patient that usually would have been at the hospital, they were just sent back home. So that's but this technology has never been to space yet because we have never been to Mars. So already being used on Earth before being used in space, but developed for space.
Yeah, we just heard a lot has been invented already and done in space. However, we see that differently a little bit because we think we are just standing at the beginning of something new. And this has reasons, because if you look a little bit to the research, which has done, conducted in space, life sciences, but also material science, it's mostly science financed by state. And this is not a really the environment where you can totally create innovation. You have to become public and also to gain the interest of the private industry. And there's a big change ongoing right now, at least in the last 9 years. When we started 9 years ago, just to give you an example, for life science experience, the ISS, the International Space Station, is the main platform. Because you can easily bring back the results of an experiment. But there are only about 150 experiments done per year, nothing more, approximately. I mean, this is nothing, it doesn't exist. And there's a reason for that. 9 years ago, you had to wait 5 to 7 years to get an admission to the ISS. You weren't sure whether you finally get accepted or not. It cost millions. You had to, each time you had to basically start from scratch to develop a lab, etc., etc. And finally, you had to give your lab to the NASA, and they then have the control over it over the whole period. That means you cannot interact with the whole period of the experiment, which is a huge handicap. And this is not exactly the environment you want if you're a researcher and you really want to do some research in space. It should be easy, it should be cheap and reproducible, and so with little effort. And well, I cannot make publicity for my company here, but this is exactly what we try to do, to develop the systems and let's say the end-to-end systems to make this happen. But there's still a long way to go. But I think from that point of view, in the last 9 years, a lot has changed. Only launching, for instance, with the openness of space to commercial, the launching prices dropped dramatically. It's just an example. Also, the possibilities to go on a flight. Before, we had to wait 1 year to find a place for our microsatellites. Today, it's a matter of 30 days, and we find a slot. So there's a huge change ongoing.
Yeah, for sure. For sure. In space is becoming more accessible, and this research also is, as we mentioned, useful on Earth. A couple useful during this pandemic.
Well, actually, I have again to talk about my company, sorry, but we are a little bit unique at the moment still. We developed some solutions for monoclonal antibodies and also mRNA, which are key figures at the moment in COVID research for vaccination. And so theoretically, it's possible to do something. And just to give you as an anecdote something, speaking about monoclonal antibodies, those are proteins, but small ones, small molecules. And when we had 9 years ago, we had a workshop with a specialist in this domain who does research, and he told us, well, you can imagine gravity, yeah, that can influence big molecules, but for small molecules, that's not possible. It makes no sense. And today we have experiments, and we can show that there's a dramatic influence. And so going to space, we have to prove that, of course, but it could be that over this way we can get to new indications and better indications, because you have the big chance with the molecules you are studying in space to get to the pure form, which is not influenced by gravity, which has a lot of advantages in terms of drug development.
And may I ask a question to Martin?
Yeah, sure.
Yeah, so I fully agree with what you said. On the French Space Agency side, we also are operating a market stimulation program in the field of biomanufacturing. So it's exactly what you just described.
Okay,
My question to you is quite simple. Once you have developed your experiment in space and you have gathered all your scientific information, I understand that it's a proprietary of the company that has sponsored somehow the experiment. How do you transform this experiment in space into a terrestrial value proposition for like market access on Earth? Basically, what's the next step after your space experiment?
That's not easy to answer. Working in space in the medical field is not yet a standard practice. And it also can touch legislation. For instance, we have a plan to even produce drugs or components of drugs in space. It's possible. We have the technology for it. I think on the ESA project with Space Rider and those new spacecraft, the mini shuttles, that's perfect environment for such applications. But it's a good question. For instance, if you do something like that, like production, and you bring the product back to Earth, also the health authorities have to accept that. There's no really regulation existing, which is treating that. That's also a little bit a challenge, which is going in parallel, if you will.
Perhaps in a more general sense, I think the space sector is changing with a focus on stronger commercialization, as Lucy and Martin said. I mean, of course, it was dominated by institutions throughout the last decades, but which was also part of the risk sharing of the development of the associated hardware of taking that risk. It's good to see an example of so-called new space companies, but I think a couple of had been developed during the last years, and I'm thinking about Ice Cubes, I'm thinking about Bioreactor Express, I'm thinking about Bartolomeo. So slowly things are moving. Even, of course, the institutional track is still dominated, where you have to apply, where it takes time sometimes to apply. So very great to see these new opportunities. And I think the health sector, on the other hand, is also changing, right, very much, where we see new startups, where we see a stronger focus on data science, the whole trend of wearables, everything what needs connectivity. So I think we will see much more possibilities, not only for microgravity research, but of course as a big pillar of this.
Christophe at CME also works towards commercialization technology.
Yes, so but this is more in the wearable or hardware side. So I mentioned the one we developed for this way to Mars, and of course there's all this technology transfer program from the European Space Agency, where so it's not one-to-one technology, but the know-how that we developed that we applied for issues on Earth, and for instance we've been working on this. For this for these astronauts, but now there are wearables for athletes for that. Or we also develop fetal ECG for monitoring the mother and the baby at the same time, based on the technology we developed for space. So that's a big part of the European Space Agency to see that actually everything that is developed is used afterward for everyone. And if there are side application, they help us to find startups or go to the market with this technology one way or another.
And so
Chloe, you had a
about,
question.
oh.
Sorry. Oh, sorry. You had a question about pandemic. Is that correct? Do you hear me?
Yes, exactly. If space contributed, yeah.
Okay. So maybe I
I might
can give a
answer.
little bit of insight.
Delay.
Yeah, a little bit, but no worries. So when we first went into the confinement in early last year, we gathered with all the other space agency, including our ESA colleagues, but also Mexican space agencies, to ask ourselves like how can space help in this current pandemic, and what do we have already almost ready for different applications that can be somehow a little bit modified and used in very short time. So we discussed a lot, and as Sasha mentioned, we first look at all the satellite data. So talking about Earth observation data, telecommunication, and navigation. And we tried to make especially satellite communication available for remote area in order to help the diagnostic and the prevention of people that could have been infected by COVID-19, and in order to support the practitioner on the field to see if they have to send a specific patient to an hospital, or if they can stabilize these people on the field. So basically it was a kind of triage activity. And then for Earth observation, what's important to understand is that COVID-19 is not an environment-related disease, meaning that there is no favorable environment that is linked so far, by the scientific knowledge I know, linked to the spread of the virus. So it's more person to person. So it was complicated to correlate environmental data to COVID-19 cases, except for the fact that maybe pollution could have an impact. So we looked, there was a paper published early 2020 to demonstrate that where you have lots of pollution and lots of particles in the air, the virus is more keen to spread to longer distance, and therefore you have an increase of your pandemic impact. So we try to really did all this kind of project. Sorry, but the key message here is that if you're not prepared for a pandemic, if you don't have the tools already in place, it's quite complicated to have a successful project in a very short time. It's not due to the space sector, but also to the organization on ground, meaning if I come back to the example of space telecommunication, if you don't have your setup, your operational setup in place with a doctor that is in charge, with a telecommunication link that is established, at one point it can take a little bit time so that they acculturate to this new practice. So my key message is preparedness, 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 and I think we should invest on that. And maybe for human space flight spin-off, my colleague have something to say about the pandemic.
For the pandemic, I can definitely say a lot of resources had been mobilized, right, by national member states, but then also by ESA. There were a lot of immediate tenders for COVID-19 measures, actions, and applications. If you also think about all the COVID tracking applications, most of them are based on actually Galileo, our European GPS system. They're using it for understanding where you are and where other people were. Then afterwards, there was also a shift together with the Commission. If you think about RACE, so the Rapid Action Coronavirus Earth Observation Dashboard, to really understand the consequences of the pandemic on a larger European scale, on air pollution, but also water pollution and the changes which were associated to it. In a lot of countries, harvesting was difficult. So with Earth observation, there were also analyses going on to better plan this. I like, Lucy, what you said about being prepared, and I think being prepared is also part of the whole thinking of One Health, right? Where are we humans? What is happening with regard to land change, land degradation, and then also interaction with animals. 75% of emerging infectious diseases are zoonotic by origin. And the whole field of remote sensing and teleepidemiology with data from space, so to understand what is climate change doing, what is happening with regard to land change and human influence on it, and what are developing factors, if you think about rainfall, temperature rise, but also you can include socioeconomic data to better understand how certain pandemics could emerge, and how could we build early warning system, including the modeling aspect and the mapping for the potential identification of hotspots. So I think there was a whole awareness change of this, and there's something going on already in the space industry for a while. And perhaps it's not COVID specific, but it shows us that there's still a lot of work to do, and that there also needs investment to be done from the public side, but then also from the private side, because I think commercial actors are also interested to identify what are these emerging spreads. And what are potential vaccines or ways of dealing with it?
Mention the economic impact of the pandemic. Sorry. Go ahead, Chloe.
No, I was. It's crazy how space is useful in various fields.
I just wanted to add the economic impact. Like all the industrial sectors have would like to prevent this kind of situation, because when you look through space, all the economic data, like you see less traffic, less boat traffic, less train traffic, all the factory that has been stopped, there has been a huge economic impact that can be monitored and follow up from space. So I think also space can use not only as direct for the medical field, but also for all the other industrial sectors.
And so, talking about opportunities in the market, Martin, so you created Space Pharma a couple of years ago. How do you see your company entering the space market? Now, I was just talking about how the Space Pharma sees the opportunity of this new private space developing.
You mean in terms of pandemic?
Now, more in a general sense, with the rise of private space and new space, as Sasha mentioned early on.
Well, the potential is huge, in fact. We just discussed the COVID pandemics. To give you an example, if you do research on factories, for instance, very often minerals is not high than on Earth. Also, the production side that in the you work with bacteria. It's just an example.
I'm not sure we can hear you well. Am I the only one?
Okay. I don't know what happened. Huh. Okay. Is that better?
Um, a bit, yes. Yes, it's a bit better.
Is that better?
Yes,
Okay,
perfect.
better?
Way better. Yeah, way better.
Okay, sorry. Once again, we just mentioned a pandemic. If we do research in space, a lot, for instance, Syria very often, and also have a much faster development cycles because they can grow in 3 dimensions if you want, in microgravity conditions. Similar, well, so observe in other domains, for instance, in genomics, potentialization, of course, lateral chip technology, etc., etc. There's a lot of potential in it, but accessibility is a key. And that's why I'm very, well, let's say, we are very interested in this new development, which is taking shape with the new generation of mini shuttles or spacecraft, like the Space Rider. Other products also exist by other nations. And this really helps to make something, accessibility to space, something common. And then we can enter into also the new field of application in terms of the private industry. And I think that's very promising. And there's a lot of, as I said, a lot of potential in it.
Thank you, Martin. So talking about going into space, in your opinion, what are the challenges that it puts on the human body when in space, for instance, on board the International Space Station?
I can start on that. So there are the two first challenges for the human body in space are microgravity and radiation. On the International Space Station, radiation, for example, is less a problem than for longer missions such as Moon and Mars, because we are still within the protection of the Earth's magnetosphere. So there is the protection of the shielding of the International Space Station, the monitoring of all the radiations that can occur on the human body, but also we are in a kind of protected area. Nevertheless, we have done lots of experiments on rodents, for example, or animals, because in an ethical point of view, it's much more easier. And there has been demonstrated that radiation for the future could have a huge impact on the body. On one side, it will accelerate the cell degeneration, I don't know how to say that, and on the other hand, it could induce some cancer for the future. When we speak about microgravity, it's another story. It affects the entire body, so you have to do integrated physiology. You cannot look only at a subsystem such as muscle or bones or metabolism, because everything is correlated. So you find impact on the cardiovascular system for sure, because your heart, which is a muscle, doesn't function in the same way. It doesn't have the gravity, so it has somehow it strains a little bit, and it has to push stronger towards the head and the torso area. You have also impact on the metabolism. It doesn't work in the same way. So there is lots of study right now to understand what's the correct amount of food and macro and micronutrients that would be necessary for an astronaut to function properly. And this is also linked to the muscle loss, because there is a strong link between nutritional assessment and physical fitness. So you have muscle loss because you don't really move in the same way, you don't walk and so on, you don't need like strong force, so you have your muscles that get weaker and take less volume. And then, of course, you have bone demineralization that is also strongly linked to nutrition and to muscle loss. So everything is really correlated. So at the end, it's like the astronaut is becoming an older person in a shorter time, and a person that lack physical activity. For example, when you have to stay in bed because you're ill, you experience some of this kind of impact. So, and there is other impact. Maybe I will let my colleagues talk about it, about psychological effect, neuroscience, immunology, and also host microorganism interaction. So lots of things.
Yeah, there's also another aspect of, do you hear me, of health of astronauts, deep space missions. That's they don't have a doctor with them in the pharmacy. So personalized medicine is the key, in fact. And in doing this today, what's very interesting as a method is a lab on a chip or organ on a chip, where we try to find ways to mimic the body of somebody, and then directly can do your studies on a chip, in fact, on the cells you have. And this interaction then used to allocate the right medication. This is a technology, the idea, I think, basically came because of the astronauts, but which is a technique which basically then also can be used on Earth, of course. And it's on right now in research.
Sure. And Christophe, I don't know if you're still with us.
Yeah, I'm still there. But yeah, well,
Maybe not,
we
but the CSEM also works a lot on developing digital technologies that help, well, monitoring health on the space station, and then also useful back on Earth. Lucy, you've mentioned nutrition before. What are the differences between nutrition on Earth and in space? The
So
nutrition needs, let's say.
yeah, the nutrition needs are a little bit different, but what we tend to observe, it's also personalized. So we are really going towards personalized medicine, personalized protocol, meaning that one individual astronaut doesn't have the same need as his colleague, even if they are roughly, the same height, the same weight, and the same body type. I don't know. So what we have seen, for example, that there is a need of protein increase. That is quite important. There are a need of calorie increase, like general calories. They tend to require more intake. So this is quite difficult to understand, because when you think about it, they are less moving. But what you have to know is that in terms of countermeasure for bone and muscle loss, we ask them to do 2 hours of exercise per day. So somehow you have to find the right balance and compensate that. There is also a need to increase certain type of vitamins and to decrease sodium intake. It has been demonstrated during an experiment on the International Space Station called SOLO that when you have too much salt, somehow in your food, this can affect your metabolism and your system. So this is not recommended for astronauts. But there is also something that is important to understand, is that food is not only for nutritional assessment, but it's also for psychological well-being. You have different cultural background in space. They are really constrained during the day in terms of planning. They need to be very operational. They have lots of activity. So somehow food, it's still their freedom. It's part of their freedom of choice. So how to find the right balance between asking them to really be in line with what are the requirements for space flights, and giving them freedom of taste, of well, they can eat somehow what they want. And this is really a difficult thing to do. We are working a lot on it, especially with our ESA counterpart from the ESA Astronaut Center. We try to elaborate some menu that can be appealing, that has good taste, with much more less salt. So you have to find other way. On the top of that, you increase the food safety problems. So it's a complicated field. We don't know everything yet. It's very touchy, because when we have experienced that when we touch on food for some astronauts, it can be very complicated. It's something that is cultural, and it's not only scientific. So to give you an anecdote, we were performing an experiment called Energy, maybe you heard of that, on metabolism. And we have asked for the scientific requirement an astronaut not to drink any coffee in the morning because it impacts the metabolism. And then after that, we were doing some basal measurement. And this was a huge deal. It was, when you think about it, it's just waiting to take your coffee. But it was something huge because they have been since like 3 or 4 months in space, and at somehow they wanted to drink their coffee at the right time. And you cannot neglect all this. It's not only a scientific purposes. That's my message.
I would be curious to hear our astronauts. Luca Parmigiano was yesterday also at Viva Tech about this, especially the taste aspects.
You
Would
can
be
ask
curious.
him. He will remember energy experiment. He will say very unkind word maybe about this coffee story.
But perhaps coming back, I mean, space medicine had been, I think, also the front runner of personalized medicine, and I think it's a future. We see this development, prevention, personalized medicine, and what is especially important for the ISS or human spaceflight in general is also there are no doctors around, as we have heard before, to increase shelf life. Of potential medication. It's relevant on Earth as much as in space, especially for long duration missions, but also eventually to produce highly personalized medicine on the spot. And I think the whole industry is also looking at this. It is quite fascinating, and I think it gives us a little bit the glance of the future development. And for those who want to experience, and I don't know, Chloe, if you have already sent out your application until tomorrow, ESA is still looking for astronauts. It's a milestone since many years, I think even 2009, right? It's the first time that astronauts are being looked for. Also, the para-astronaut feasibility study is interesting to look at people with special needs and the possibilities of going to space. So it's also part of the democratization of space. So not only in commercial aspects, but I think also for people, it is widening up a little bit and slowly, but it is widening up. So there are definitely more to come.
I'm too young. I'm still a student of EPFL, so I need to wait at least 3 more years. But now that we know that we have personalized menus on the ISS, that is more attractive. Well, Sasha, you mentioned it, but with all this innovation coming up, how do you see the future of health in space and
I would rather concentrate on the commercial aspects than the specific solution itself, because as we see with Martin, there are more and more commercial players, and I think it's very much in the interest of the industry, but also for the space agencies we're going to see more partnerships here. In different areas, if it's really supporting the LEO economy itself, but also, of course, terrestrial applications. With the digitalization of the whole health sector, we need connectivity, we need telehealth, we need prevention, we need wearables, we need to understand this. But for this, we also need new partnerships. We have to work together with different types of startups. We have to work with larger companies, but we also have to work with hospitals, with cities, and with regions. So I think the whole spectrum of interaction is certainly getting more complex and complicated, also on our side. But it's interesting because new people getting involved, new people getting in touch with space infrastructure, and we are not always aware where space is and how we are using space. So there's definitely more to come in this. I think the shift from scientific technology push to starting to have a market pull in this area is important. And of course, from all of us, it will also ask for new ways of working, new commercially driven partnerships. So yeah, for me, it's very much about this. And then innovation will emerge, and then innovation will come, and it will be filled by the private sector. It will be filled by young, smart people setting up startups, and which solution it is exactly we'll be going to see.
Yeah, I think it's really interesting
yes,
what
and among companies. We have Space Pharma, for instance. So how do you see the future of health?
Sorry, do you hear me?
We cannot hear you very well.
So better. As I told you, the key
Way
one
better.
of the key is accessibility, and right now, as we heard, a lot of initiatives are ongoing right now, privately, but also from institutions, in terms of especially the new generation of mini shuttles, and if they really go up, it's an advantage in terms of for research to make the easier and the accessibility much easier, and it has also a huge impact on the prices. But there's another issue which is more political, if you want, which we cannot solve like that. But if you think on it, if you take cars or trains, trains have rain tracks, car have. Who is financing those infrastructure? Is the state mainly, and maybe something else similar can be done or achieved in space to really put accessibility to it, and that would be something which must be in a partnership, of course, with all the partners. But that could be something which really is helping research and space can taking up.
And how about you, Lucy? How do you see the future of health and space?
I think it will be, sorry, I think the future for space and health will be a mix between what has been done before, which is like fundamental research, mostly supported by institution and public fund, and commercial, I won't say application, but commercial initiative that involve a lot of non-space user or non-space company. I believe, that's my personal point of view, is that the moment in the past where space in terms of health was in advance, meaning that we were developing high-tech technology for our own needs, is not the sustainable model anymore, and that we have somehow to source and to partner with companies or public laboratories such as CSEM that we have today in order to gather our force, our expertise, our knowledge, and to develop technologies that can assess both need from Earth and from space. When you think about it, there is lots of commonality in the problems. So the idea, what I try to push at the French Space Agency, it's to identify common need. For example, Christophe mentioned it, the monitoring of vital sign and the detection of early warning system in terms of physiological deviation. This can be useful for Earth and for space. So the idea is that we start together at the beginning of the project, we identify our needs, we push forward the technology, and at one point, of course, you will have a specific space application because we have specific constraints and a market reach from terrestrial point of view. And I believe that we are not talking anymore about spin-in and spin-off, but like a common innovation. And companies such as Space Pharma can help for that, because it's the same way for, Martin mentioned protein crystallization and new antibody discovery, drug discovery. It's the same way. It's basically we partner, we look at our current problem, we say, what's your strategy on the terrestrial market access, how we can help, how it's benefit also the general space system, and we work together. That's my point of view for the future of health and space.
So a
Do you hear
collaborative
me?
future. And how about you, Christophe? I don't know if you're still with us.
Yeah, but I try to. Do you hear me? Yes. Okay, because I tried to speak several times, but somehow I think you didn't hear me. So, yeah, what I wanted to add also.
Am I the only one not seeing and hearing Christophe, or?
We can hear him and see him very well.
Okay,
And we can hear you and see you, Christophe.
Okay, thanks. So
Okay, I am not able for.
I'm reassured because
my apologies.
yeah, when I tried to intervene, I was just out. So yeah, just to complete what you said, Sasha, we also had some about personalized medicine being developed for space. You have to be careful because it's actually biased. When we first worked on some wearables to measure vital signs for astronauts, everything was working very fine because astronauts are healthy people with a lot of muscles, where you can really have a strong attachment of the sensor. You can press on them, and everything is fine, and everything was working perfectly. And then you go to some patient or some patient with chronic disease, or just people with different physiology, like they are not so healthy and muscles and all that, and suddenly things don't work the same way. So we've learned also to be very careful in transferring space to Earth, because when you believe, I mean, sometimes it can be stupid. We started measuring all this on mail because that's what the European Space Agency was as a requirement to test on astronauts. And then when we first started on our female colleagues, things were not working the same way at all. So that's what Lucy said about the physiology being complex and everything working together. So taking only what is from space is actually biased. So we have to be really careful. And I've seen as well that to when you say it's good for private company, I've seen also a couple of companies we're working with, startups, or they have products, and I think it's also a good opportunity for them, like marketing to show that their product is on the ISS, or is used on some astronaut, and then they can show that to the customer, and they get so this also a part which is not necessarily completely, let's say, scientific, but it is helping them a lot as well. But we need to be careful transferring to astronauts. So when you say, for the astronauts, it's now opening and they are looking for more and for more diversity, maybe we have to be careful that the system will keep working the same way.
Chloe, I don't know if you could hear this. Okay.
Poor Chloe.
Stuff. I cannot see or hear you. I'm so sorry. I don't know why. Just say the stream. So I'm sure that was very interesting.
It was. In a nutshell, maybe we can summarize for you what Christophe just said. So sorry, Christophe, interrupt me if it's not correct.
Go ahead, it's fine.
He says that, and I fully agree with that, we have to be careful in how we transfer the knowledge and the technological demonstration from astronaut to Earth, because astronaut is a very specific population. It's mostly male, so there is a bias, an unused bias to develop things for male, with a lot of muscles that are healthy, so they don't have any comorbidity, for example. And what they found out is that when they transfer a monitoring system, yeah, that's correct, for larger crowd of patients, a cohort of patients, that for female person it was not working because it was not by design included, as far as I understood, in the initial project that was meant for space. So we have also to be inclusive. Christophe, did I summarize?
It was included, but actually it was actually didn't work. So we it was a good way to learn additional thing and to
I can only
understand and to
agree
make it
with,
work. But
with
it
this
was
topic, and well, the field of space has lots of a lot of progress to do in that area. But as Sasha said, the selection, the next ESA selection also reflects this will to be more inclusive in terms of diversity, but also with the para-astronaut feasibility campaign. So we're coming to the end of our session. Maybe just a last sentence from all of you, a key message that you would like to leave our audience with.
Okay, then I start perhaps just to finish, just to say that there are plenty of possibilities, and I think it's an exciting field. I hope we're going to see more. And if you're interested in concrete opportunities, of course, also Switzerland is one of the funding members of ESA. on our website, on the Downstream Gateway website, you find a lot of possibilities. There are tenders. There are ways of working with ESA. I think also in the frame of the Agenda 2025, there will be new possibilities. So don't hesitate to have a look. Don't hesitate to get in touch and to see what together, as Lucy said before, the health and the space sector can contribute to a better life for all of us.
Thanks,
So
Sasha.
if I can just continue what Sasha said, I believe that space is an international adventure. So we are always looking for new partner. At the French Space Agency, our health team, we try to gather a community of space and non-space user or service provider or laboratory. We try to animate this community to create some opportunity for them. So if you are in any way interested in this field and you are looking for some specific partner, maybe we can introduce you to our ecosystem. Do not hesitate. I think it's too bad that our agency are sometimes working on different territories and not always together. Of course, it's the reality of the things, but do not hesitate to reach out.
Thanks, Lucy. Maybe Martin?
Again.
Yes.
Well, space. Okay. Well, for us, space is how should I say? It's a challenge. It's a challenge with seemingly a lot of potential, especially if you look at the problem we have right now. We have problem on our planet. We focus on growth. There's a way to say that this cannot go forever like this. So we need a new approach, and space offers the opportunity to grow. Offers the opportunity to look into a new world, which may change our thinking, our behavior, and even in terms of even our cultural understanding about ethics, etc. And so it's a huge challenge, but only something which should happen in a combination with everybody, so in partnership. And I think this is the most essential. And as I said before, to go into it in the next steps, it's very crucial to make it easy to access space and have the tools necessary to do it. And I think that this is one of the key components. Okay, thank you.
Thank you, Martin. And finally, Christophe, I'm sorry, I won't be able to hear it, but what is the last message?
Thanks, Chloe, and sorry for that. So yeah, for me, I would say, yeah, for the people looking for technical solutions or having ideas or whatever, even if it's not linked to space, just maybe space as a solution for you, even if you think it's completely decorrelated. So just try to come anyway and ask, and then we can see, and probably there is something also has been developed to space that can be used for other solution where we don't see the link. Thank you. So finished. I'm talking with my hands for Chloe.
Okay. He's finished. Christophe has finished.
Thanks. Well, thank you so much all for joining the session, and I guess we will look at space and health from a different angle as of now, and we will meet again at 5 if you'd like to join for another session.
Thank you very much.
Yes.
Thank you. Bye-bye.
Bye-bye.
Bye.
Bye-bye.